Alright guys, welcome to PreCalc. This is 411 day 2. So we're going to pick up where we left off last time. So we kind of went over how we can um, kind of make a graphical prediction based off of these kind of factored forms of polynomials. So using those rules that we talked about last time, for A through J here, we're just going to go ahead and do a quick sketch of what those are going to what those graphs would be. So things that you want to prioritize are going to be: do you have the right x-intercepts? Do you have it going through those x-intercepts in the right way? Does it go through? Does it wickle through? Does it bounce off? Stuff like that. And then the end behavior. Those are the things that we really care about. So go ahead, pause the video, work through those, and see what you get. Okay, so I'm not going to go through all these just because there's quite a few here. But let's look at like R. So R is going to be a third degree polynomial, so it should be going down on the left and up on the right. It'll come up and then it'll bounce off at -7, and then it'll go back up through at +5, and then keep on going up and up and up. All right. So that's the kind of thing which we should be able to do fairly easily and fairly quickly. Take a look at, say, F. Here it's an even number power, so it'll be going up and up, but this negative means that it's going to be flipped, so now it's actually going down and down. So once we have that rule, you can say, well, it'll come up from the bottom, then it'll bounce at -1, then it'll come up and bounce again at -2, and then keep on going back down. So this is the kind of thing that we're looking at being able to do fairly easily and fairly quickly. Right? And once you kind of get the hang of those rules and how these work, these actually go pretty darn fast for us. So let's take a look at 3 and 4. So 3, we're going to talk about the ideal of roots and real roots. So roots are the values which cause a function to equal 0. They're also called zeros if they're on a graph. They're called solutions if you're trying to solve them out algebraically. All different ways of kind of saying the exact same thing. When you say a real root, it means it has to be a real number, meaning it's going to appear on our real number line, and since our x-axis is a real number line, it's going to have an x-intercept. That's effectively what is going to happen here. So if I have a polynomial of third degree, it'll have at most three different roots. And that kind of comes down to what we're seeing here. So like on part Q here, this is a third degree polynomial and it has 1, 2, 3 different roots. So we've already seen this kind of stuff, right? So what is the maximum number of real roots that a polynomial of degree n could have? So of any degree, right? So if it's a 6th degree polynomial, it can at most have 6 roots. So that your maximum number of real roots is equal to your degree of the polynomial. And that's, again, kind of what we saw here, right? If I had 3rd degree, I had at most 3 roots. Here we had a 4th degree, and I had at most 4 roots. That's kind of the rule which is going to keep on going. We also talked about double roots. Now, we didn't name them double roots, but we've seen them a bit in the past. So all of these times when you had stuff raised to the 2nd power where it just kind of bounced off, those are called double roots, because technically you're getting that same value twice. So like here, our answers are 2, -5, and then a different -5, right? So I have 1, 2, 3. So there's all 3 roots, but there's just 2 of them that are the exact same. So we don't always write out that -5 twice. We'll say, hey, it's a double root, because that is an important thing for us to know still about it. And then if we have here, with it to the 3rd power, that's a triple root, and so forth. You kind of get the naming scheme there. So this still has 4 roots. Here's 1, and then there's this triple here. Great. All right, so then on number 4, we're trying to figure out, well, what's the minimum degree that each of these equations could have, right? So this one here, it's up and up, so could it be a 2nd degree polynomial? Well, no, right? And that's because if this were to cross the x-axis, and I like right through here, I would have 1, 2, 3, 4 x-intercepts. So that means it has to have at least 4 roots. So could it be 6? Yeah. Could it be 8? Yeah. It could be any even number of degrees, that is 4th or higher. But again, we're looking for the minimum because we're always going to be trying to find the simplest one possible. So on 2, again, they both go the same directions, so it's going to be even. Could it be a second degree? Yeah, because I would cross at only 2 points if I put my x-axis through here. Now, even though I could put my x-axis here and cross at no places, we're looking for the minimum, and it would be 2 because I'm crossing here and here. For I could cross it 1, 2, 3, 4, 5 places if I went right through here. So this would at least be a 5th degree polynomial. And then for 4, I could cross it 1, 2, 3. So this would at least be a 3rd degree polynomial. Now there's some kind of rules here with like number of bins and stuff like that. And you can use those rules, but once you kind of get the hang of it, just thinking about, well, if I drew the line through here, how many times would I cross? So just going to keep that in mind for trying to figure out what the degree of the polynomial is. So could graph 2 be a 4th degree polynomial? Yeah, right. It could be, and just have like have all 4 roots be the same and just bounce off of that same place. Not a big deal. It can happen, but that just wouldn't be the minimum one, right? Well, could it be a 5th degree polynomial? Well, this is one where it's a hard no, because the 5th degree would have a different in behavior than we're seeing here. So that's the one that we can say a definitive no on that one. And then this kind of goes into the kind of rule which we've talked about the number of curves and number of x, intercepts. How do we figure out that degree or the minimum degree that it could be? All right, so a few little quick notes here. Polynomials, we've covered these for the past however many years, right? It just means it has many terms. So like quadratics and cubics, you've seen all of these. There's not going to be fractions and things on the bottom. We typically write them from the largest power of x down to the smallest power of x. Stuff like that. And then again, we define the degree as the largest power in that polynomial. All right, so our final thing here that we're going to do is, this is going to feel a little bit silly, but actually do this with your like finger, but we're going to trace what this would look like. I'm going to turn around so that you can kind of see me, not have to try and mirror it, because that's really difficult for me. So we're going to trace what this would look like. So this first one is going to go, it's a 3rd degree polynomial, so it'll start low and it'll end high. So we're going to go up through -9, down through -6, up through +10. Next one is negative and 3rd degree, so it'll actually start high, it'll go down through -5, up through -3, down through +4. Okay. And then the fourth one here, it's a fifth degree, so it'll start down low, and then it'll go up through -8, down through -3, up through +4, down through +9, up through +15. And then the last one, it's a 4th degree and negative, so it's going to start low and end low, so it'll go up through -5, down through -2, up through +4, down through +10. Awesome. So once you kind of get how these work, again, they're not very difficult. There's not some crazy trick or challenge to all these. It's just kind of following these fairly basic rules. So with that, here is our assignment for day 2 of 411, and I will talk to you guys next time.